And lesson 98 is going to have some contrived log problems. In other words, some kind of weird ones, and only because they have special characteristics will they actually be ones that we can work through and solve. And we also are going to talk about change of base. If you don't have an Inspire calculator, or if you are in press to test mode, and you can only do common logs and natural logs, but you have a problem base 8 or something, how can you change it to be able to solve it? So let's get started here. First example, if you needed log base 8 of 18 and you're not allowed to use the Inspire function where you punch in the 8 and the 18. These first two I'm going to do the long way, but then we'll get the formula, and then on problems you'll do it the shortcut way. But let's copy down the proof of this. So I want to find that, so I'm going to say that equals x, and I need to figure out what x is. That's equivalent to saying evaluate that. So with my properties, if I change it to exponential form, that means 8 to the x is 18. And then we can take some log of that. Let's do this one with common logs. Let's take the common log of both sides. And what can I do with the left side? Parker, what can I do with the left side? When I have log of something with an exponent, what can I do with that exponent? Thumbs up or down? Everybody good with that much? I'm looking at home too. Everybody good with that much? So now, much like you've done on other problems, if I want just x, I'm going to divide both sides by log 8. And we punch that in on our calculators. A couple of you are right on top of that, getting that done real fast. And Emily, what you come up with? 1.390, and we just evaluated that. And if you don't necessarily believe me, punch it in as log base 8 of 18 and get the very same thing. So are we good with that? Okay, I'm going to do another one, but this time I'm going to do it with natural log instead of common log. And then I'm going to see if I notice a pattern that would let me have a formula. So I'm going to do the same thing. I'm going to say that is x, and this problem says let's find x. So converting it to exponential form, 3 to the x is 72. This time let's take the natural log of both sides, and let's use our property that says we can bring our exponent out in front. And then if I divide both sides by natural log of 3, please punch that into your calculators. And Robbie? 3.893. And somebody punch it in this way, log base 3 of 72, and verify that we also get 3.893. So we're convinced that whatever we just did works, and we're getting the same answer. And we did it this way using just natural logs. And on this first problem, we did it using just common logs, even though we didn't start out with base E or base 10 on either of these. So let's look for our pattern. I had log base 8 of 18, and I evaluated that as log 18 over log 8. I had 18 up high, 8 down low, and then when I converted it to log over log, I still had the 18 up high and the 8 down low. What happened with the next one? I evaluated log base 3 of 72, where the 3 was the lower part, it was the base, and the 72 was higher, and I had 72 up higher than 3 when I changed them both to natural logs. So when you're doing these on homework ones, and it says to evaluate something like log base 5 of 24, and that's all it says, you must write down the change of base formula and punch it into your calculator with either ln or log, and the formula you will use, if it is the log base b of a, you will do either common logs for both or natural logs for both, but you'll keep the a up higher than the b. And as always, a has to be a positive number, or we wouldn't be able to take the log base b of a in the first place. So on a problem set, if you have log base 5 of 24, you will not go through all of that stuff we just did. You will write down either log 24 over log 5 or ln 24 over ln 5. I must see one of these on your paper. That's all the work you show. You don't do all of that to the x and taking logs and converting to exponential like we did on the 2 examples. That was just to see the pattern. This is all you write down, punch in on your calculators, and then write down 1.975 as your answer. Nice little shortcut, right? Questions on that from anybody in class or at home? Okay, let's do our contrived log problems. And this is log of x times x. This one means the log of x times the log of x. The one on the left does not mean log x times log x. So first thing is, do we understand what it means wherever the square is? The square is only on the last thing you would type before you hit square. So on this first one, the last character you type is an x, so only the x gets squared. On this one, the last character before you type the exponent would be the parentheses, so the whole parentheses gets squared. In order to do these, we are going to do a couple of things. With the left-hand side, we're going to use our property with the exponent, but we can bring it out in front. So I have 2 times the log of x equals the log of x times the log of x. Then with these contrived log problems, we're going to do our substitution. We've already used x, so any different letter, Greek, English, whatever you like, I'm going to pick a. And I'm going to let that be the log of x, so I can look and see if there's a pattern that I recognize. So I am going to say 2a equals a squared. Can I divide both sides by a? No, because a might be 0. Log of x might be 0. So I cannot divide by a. Because a or log x might equal 0. So instead, what I need to do is to get everything on one side equals 0 and then solve my quadratic. So if I have a squared minus 2a equals 0, can I factor that? What can I do in order to factor that? So we're going to factor out an a times a minus 2. Keep that equal to 0. Factoring works only if equal to 0. So a could be 0 or a could be 2. But a is really the common log of x. And now I can convert those to exponential form. I can say 10 to the 0 is x, and 10 squared is x. So x is either 1 or 100. Thumbs up, thumbs down. Joe, I can't see you on screen anymore. Thumbs up, thumbs down in class. All right, let's do another contrived log problem. And we're going to use a similar strategy here. So this one is the log of x to what power? Shout it out. To the 1/2. And this one is the whole thing the square root. So this side I'm going to write as 1/2 log x. And my other side I am going to write as the whole thing to the 1/2. Okay, now I'm going to use that same substitution. I want to let log x be replaced with some letter, so maybe I can see a pattern for solving this thing. They've used x. I take any other letter. I'm just going to stick with a. I kind of liked it. So that means I have 1/2 times a equals a to the 1/2, or the square root of a. What's our method when we're solving a radical equation? When we have root x equals, what do? We're going to square both sides on this thing. So that means I need to take this entire side and square it, and this entire side and square it. So on the right, I just have a. On the left, I have 1/2 a times 1/2 a, so I have 1/4 a squared. Can I divide by a? Nope, it might be 0, so I'm going to get everything on one side and solve the quadratic. So 1/4 a squared minus a is 0. What can I factor out? Everybody shout it out. I can factor the a out again. So I have a times 1/4 a minus 1 is 0. So either a is 0 or 1/4 a is 1, which means a would have to be 4. But I'm not finished because I need x. And a was really my log x. So log x is 0, or log x is 4. Convert to exponential. 10 to the 0 is x. 10 to the 4th is x. So anything to the 0 is 1. And this would be 1 with 4 zeros. So 10,000. Don't forget the comma. And we have solved it. Thumbs up, thumbs down for that one. Okay, 2 more. Okay, this time we have x to the log of x is 10 to the 8. This one is looking really strange. I'm going to start off on this one because I have an x in my exponent as well as a base. I'm going to start off with the method of solving an exponential equation, but I want to take a log of both sides, a log of some kind. Since I already have a log base 10, I'm going to choose to take the log base 10 of both sides. So if I take the log base 10 of the left and the log base 10 of the right, on the left-hand side I have log x to the square root of the log of x. And on the right I have log base 10 of 10 to something, so that's just going to be 8. Now I have log of something to an exponent, so I am going to bring that exponent out in front. So now I have the square root of the log of x times the log of x equals a, or 8. Same substitution as before. Any letter that I haven't already used, so I'll stick with the a. And now I'm looking at the square root of a times a whole a equals 8. And let's see, if I wanted to, I think I could combine those exponents, right? What would I get? Everybody, let's shout it out. 8 of what? I'd have 8 to the 3 halves is 8. I want 8 to the first equals, right? That's our goal when we're solving this. So the easiest way, if you have an exponent, is to raise it to another power. If I raise that to the 2/3, will I have a to the first? So a has to be. Brody, what is the cube root of 8? And then 2 squared, everybody? So a would have to be 4 for this one. I got one answer that I'm coming up with now, but a is really log x, so that means log base 10 of x has to be 4, so 10 to the 4th is x, and again, that's 1 with 4 zeros after it, so x is 10,000, and don't forget the comma. Good with that one. All right, very last one. The log base 10 of the log base 10 of x is 3. So what I am going to do here, so I'm going to write that one in, and I'm going to change it to exponential form. So I'm going to say 10 cubed is my original base, log base 10 of x. Okay, I want to get rid of that log because I want just x, right? So I need to exponentiate both sides. Or I could take 10 cubed equals log base 10 of x and convert that to exponential form and get the very same thing. This cancels out. X equals 10 to the 1 with 3 zeros is 1,000. Do you think I'm going to be able to display that on the calculator? 1 with 1,000 zeros after it. It's going to say overflow. Do you think you could write it out on your paper, 1 with 1,000 zeros after it, and get all the commas in the right place? So I think because of the size of this one, we will just leave it in more or less exponential form, although we don't need to write in the 1 times 10 to the 1,000. Everybody good with that?